Hello, so I am simulating here a pavement with a few layers. I think I have 5 layers for this one, and I'm simulating a airplane with tridem wheels and tridem axles with 6 wheels. So I just wanted to start showing how am I defining the mesh for this model. Okay, so let's do it. I'll do a little piece. I've pretty much finished most of it, but let's do a little bit of it together. Alright, so at the bottom, okay, so after assembling all layers together, that's how my structure looks like. So we actually have 6 layers. So what I'm doing here, I am simulating it considering that the structure has symmetry. So if you see, I only simulated half of a wheel here and one whole wheel right here. But when we show the whole structure, we'll see that this will be mirrored to this side and to the other side. So we'll have the structure in as a whole. So we'll have the 6 wheels. So don't worry. Let me show you how we do the load definition. So before, let me see, I had something just to test. We're gonna delete this. Let's create a new one. So it's a pressure and it will be applied in step 1. Now it's asking us to select which area. So this is the area right here. Right? And the magnitude, let me check. Is 0.53. So 1.53 megapascal in this case, because I used my length in millimeters. So all other dimensions are in millimeters, and the pressure and load and the stiffness of the material, everything will be in megapascal. Cool, so we have our load applied right here. Okay, so what we're gonna do together now is the application of the constraints. So let me see, I had something here before, I might have to erase. Let's see, in the bottom, okay, it's saying that parts were modified. So we're gonna have to erase all I have here. Yes. Let me pause because we're getting some noise. Okay, we're back. So we're gonna apply the boundary conditions. Let me start with the bottom of the structure. So I'm gonna put here bottom. This will be applied in the initial step, and this is a displacement rotation constraint. So continue. Now we're gonna select the bottom of our structure, so everything here will be selected. Let's see. Just watch out so you don't select anything you don't want. Okay, so here we want to constrain in X, Y, Z directions. Just because that's the bottom of the structure and we don't want it to move in any direction. Okay, so now we're gonna do the lateral of this pavement. So lateral, same here, displacement, rotation, initial step. Now we're gonna have to select all of this wall. So let's put my mouse on. Let me zoom into this other part. I don't know if there is another way that is more efficient to do this. If you know, please let me know. Oh no. Oh, what have I done? Okay, we'll have to start from the beginning. Yeah, there might be a better way. Let me stop recording. Right, so we selected everything we wanted. And now we're gonna constrain only the directions X and Z. We don't want to constrain the Y direction because, well, the pavement has to be free to move in the vertical direction. So we hit OK. Now we're gonna constrain the other two walls, but those two are different. So the thing here is that, so 3 in the X direction. So we want to select symmetry or anti-symmetry or encastre. So this is the option we want to select now. Again, initial step. So continue. We're selecting the, so you see that here is the X direction. So the perpendicular wall to the x-axis is this one, right? So that's the one we want to select. Right, so we have selected the wall we wanted. So now we're done and we're gonna pick this option here. So it's the X symmetry. Again, now we're gonna do the symmetry related to the Z direction. So again, symmetry, continue, and we're gonna select this wall right here. Right, okay, so we have the wall selected. Now we click OK and we select this option. So good, we're good. So we have the load applied, we have the boundary conditions in all directions we needed. Now the last step here would be to do the mesh. So okay, so to do the mesh, we have to do it part by part. What I'm gonna do here is just a very simple mesh. So I'm gonna go ahead and use the global size is 300. And we need to select the theta shape, the TET shape, because we have a wheel here that is circular, so we need the form of the mesh to be triangular. So TET, what else? I also want the mesh to be finer near where the load is going to be applied. So let me zoom in a little bit. So exactly the lines we want. So these. These. Okay, we got everything we needed. So now let me see. If we try 75, we have 3. I think I'll go for 50. Let's see. 2, 3, 4. Okay. Now we can mesh the part. Cool. So that's exactly what I wanted. You see, the mesh is finer next to the load, but it's wider where I don't need the mesh to be so small. One thing we could do here is to do the mesh a little finer next to the load and then make it coarser when it goes apart, but I'm not going to do this now. Okay, so now I gotta do this for all of the 6 layers that we have. I'll return the video when I'm done. Okay, so I'm almost done. Let's do it together for our last layer, which is our substratum. Select that, and then we're gonna mesh it. Load. Okay. And here we want the elements close to 50. And now we can mesh the part. Okay, so when we assemble, you can see that everything is tied together, everything is matching where it should. And that means our model is ready for our simulation. So here's where the load is applied. I'm gonna zoom in so you can see. All right, so okay, so we're gonna come to the job tab. First, you have to create a job I have already created, so then I can go ahead and submit. Okay, we have a problem. Let's see what it is. Okay, so because I had run another simulation in the same model, I'm getting a few problems because I changed the load and the mesh, lots of things. So basically what it is saying is that I need to fix the interaction between the layers. So here is where you define how your interaction works. So what I have defined for me is that the tangential behavior will have penalty with friction equals to 1, and the normal behavior is hard contact, which means that the surfaces cannot surpass another surface, and I'm not allowing separation after contact. I'm not allowing separation between the layers. So those are the conditions for contact between layers. So what we're gonna do now, I'm gonna go ahead and delete the contacts I already had. You can see I had defined the interaction between each of the pairs, of the layer pairs. I'm gonna delete and we'll do it together, at least one. So let's delete. Okay, so we're gonna create a new one. This is gonna be applied in the initial step. It is a surface-to-surface contact, and we're gonna call it, let me see the names of the layers. So this is the contact between the GP, which is the bituminous gravel, to our asphalt concrete. So the first layer. Okay, so what we have to do now is to disappear with the first layer. We remove the first layer so we can select this surface right here. So it's asking us to select the master surface, and that's what we're gonna do. So let's get closer. Again, we have to be very careful here. If I select anything I don't want, I'm not able to unselect it, so I have to start from scratch, which is fine. We just have to be patient. You see how we selected everything? Now we're done, and the software is asking us to choose the slave surface, the slave type, and it is surface. And now we have to select the region for the slave surface. So we'll replace all because I had disappeared with the first layer. I don't know if you remember, I hope so. And now we can remove the bottom layers. So we have to come here and select instance, and then we can remove all the other layers. So I removed everything, and now we can see the bottom of the asphalt concrete layer. So we're gonna select the bottom carefully. And now we're done. So I go ahead and click done, and you can see that the discretization method is surface to surface in this case. It is a finite sliding, and we want to select layer interaction because this is a layer interaction I had already predefined. So go ahead and click OK. Now I'm gonna put all layers back together again, and we have to find the first interaction between the first two layers. Now I have to go ahead and create and do all the same steps to all the other layers. Okay, so I finished defining all the interactions between the layers. You can see here that all of them have been created. Same procedure as I show you for the first interaction. What we're gonna do now, we'll come here again and submit. Let's see if we're not gonna have any other issue. Apparently not. Let's see. Well, okay, the analysis has started. I will stop the video again and show it to you once we have the results. Those are the results after the simulation. If you want to see how it looks like with the other parts, you can come here and you'll have a better picture of how the displacements look like. The displacements is what we're showing right now. You can see here U, it's for the displacements. If you just want to see half, you can do that as well. Yeah, it's very interesting, and simulating it using the symmetry actually saves a lot of the computational time. Yeah, so it's pretty good. So here we're looking at the displacements, as I said, but we can take a look here. For instance, if we want to see the stresses, or if we want to see the strains, for example, you can take a look. Let me see. Okay, so I want the strains in the vertical direction. That's what it looks like. Okay, I don't know if you guys already know how to collect the results. There are many ways we can do that. We can come here to get our field output, or my favorite way is to come here. Let's say I want the results for our base. So I'm gonna delete the first layer, which is the asphalt concrete, and the second layer is our bituminous base. So I'll delete that as well. Okay, now we're looking at our granular layer, and so the top of our base, granular base. And let's say I want the strains for that layer. So let me take that off to make it easier. We come here, carry, node, probe values. Okay, so I want the vertical strains for the nodes. So I could select elements or nodes. I could have components. So we have to come here and select what nodes do we want. So let's say normally I would select all of them from the area that I want to analyze, but here just select a bunch just randomly, and we write this to a file. So here we choose where we want to save. Okay, so that's it. And then we can open a file in Excel, and it's gonna look something like this. And this is actually, I was already analyzing those results before filming. So this is the maximum vertical strain that I got in the base layer, in the top of the base layer. So yeah, that's it. I hope you have learned something today. I hope you have enjoyed. Bye bye.